Okay. So what's the first step when you get an equation? Type it into your calculator, right? So let's do that. This one is missing a piece, right? It's missing x. Do you remember what I said about the missing x if you go to 34? If x is missing, the vertex and the y-intercept are the same. Like, it's kind of like you just, in this case we're talking buffalo, right? They're just gonna run and then they just jump off the cliff, right? They're not jumping up. So it kind of makes sense that it's this scenario, right? So we don't have a scenario where the y-intercept is here and then we first go up to the vertex and then down. The vertex and the y-intercept are the same. That's what's happening here. So I'll make a note of that. Okay. So I'll just say note x, right, is missing. Therefore, the y-intercept is the same thing as the vertex. Okay. See page 34, right? If you want to know what I'm talking about. So, is this crucial? No, I don't think remembering this is crucial. I think it's just that if you come across something like that, to not let that throw you off. Okay, that's all. Okay, I heard of buffaloes jumping down a cliff and can be modeled by this equation, where h of t is the height. So this is, where's h in my equation? It's here, correct? So that is the y variable. And t is time in seconds, so obviously this is going to be my x variable. So what does that mean? That every single point on this particular question is going to refer to time first and then height second. Okay? X and y are going to represent time and height. So there we go. That's probably the first step. Graph the situation, consider the scale, labels, and the shape. Well, let's make it appear on our graph first. So I hope you entered this already, and maybe you tried it already. And it doesn't look good, right? It seems like it's coming off the origin and just straight down. It's just because you're zoomed out. So I'm going to try zooming. I'm going to do a zoom standard. I like to just reset my window and then chase the curve. Obviously, this is a word problem. We're not going underground. And we don't have negative time, so we're kind of ignoring this as well. So when I'm chasing the curve, I'm focusing on this stretch here, and I need to see more up above this point. So I'm going to change what? Y max, correct? I'm going to go, what should I go? Just by looking at the equation, my y-intercept is at 32, correct? So it would make sense to change this to 35 or 40. Something like that. So there we go. That's what I want to see. So let's find, in order to graph, we need to find the y-intercept. You don't need your calculator for that. You can just get it from your equation, correct? I need you to know why. Why can't I just get it off of my equation? It's in which form? General form. Then the last constant is my y-intercept. And furthermore, if you realize this, you know that your vertex is also 0.32. But let's say you missed it. Let's go find the vertex. I can trace, what is it now? Min or max? It's max, right? So you go to the left, you go to the right, and you find out that it's, what's happening there? You see that E there? E to the negative 6, it's a really small number. It's saying 1.85 times 10 to the negative 6. That's like 0.0000185, right? That's 0 for us. So the vertex is also 0.32. Okay? And we need the x-intercept. Do I care about this x-intercept here? I don't. That's negative time. The only x-intercept that I'm going to include is this one. How do we do that again? y2 is equal to 0. Hit graph. Second, trace, intersect, right? And just go closer to that one. Enter, enter, enter. And that is 2.560. So I need you to become really good at what do I need to graph? I need my intercepts, I need my vertex. Okay? And then down the road there might be some more points that you might need. If the question says, for example, the buffalo lands, I don't know, on a small little platform. Not that that would ever happen, right? Buffalo wouldn't, but a clown can jump on a platform or something like that. Then you're not necessarily going to touch the ground. We're going to talk about that later. Do I have everything I need? I would argue yes. I'm just going to make sure I show how I got everything. Second trace 5 to get this one. To get the y-intercept, I just read it. Read it off and this one, sure, maybe you missed it. This will be second trace max. But really, you know that I just read it, correct? I just knew these were the same because x is missing. As soon as you have the y-intercept, you also have the vertex. Let's graph it. Arrowheads, this is time. Just time is not good enough, okay? You need to go time, and what is it measured in? What are the units? It's in seconds. This will be height, and we are in feet, correct? And do you notice that it says above the ground, right? It's the height above the ground, so we're not going underground. If it said, just look up here where my pencil is, if it says it's the height with respect to the ground, then you could possibly down the road have a negative. Like if you're diving and you're going underwater, then you would have a negative height, right? Because it's with respect to the ground. Ground is 0, correct? So there are some things you need to just, you're going to have to encounter them to know what's what, right? So 0.32, so if I make 5, 10, no, that's not going to work. I know that already. 10, 20, 30, that's probably the easiest to go with here. Because I need 32 to show up. So this is 35, correct? This is 35. This would be 32.5. So 32 is right about there. And then for my x-intercept, I need 2.56. I think you have enough room to go up by 0.5. If this is 0.5 and this is 1, 1.52, right? 1.52, and this is 2.5. It's a little tight, but it will work. It will work. So 2.56 is somewhere here. And how does this work? You don't have anything else, so that's basically it. So you curve out. Right, there you go. And if you had different scale here, yours might go steeper, like straight down like this. That's okay, as long as it lands on 2.56. That is the graph. I'm missing my label here. And sometimes it's probably smarter to first answer all the questions before you graph. I'm just saying. Because then you'll find a bunch of points that it's like, oh, I'm finding x-intercept anyways, right? So B, let's answer that. What we just did here is just answering A. How long are the buffalo above the ground? That would be the x-intercept, correct? I already have the x-intercept. That's 2.560. So here you just need to answer 2.56 seconds. Okay, you clearly indicate that's what I'm after here, 2.56 seconds. How about no keystrokes, Mr. Dirksen? Yeah, you already did that, right? So on applied, we're kind of like if you show us the work somewhere on that page, you're fine. C, what is the initial height of the buffalo? What is that? That would be the y-intercept, correct? The initial height happens at time 0. So it's the y-intercept, 0.32, but you need to actually state 32 feet. Okay. 32 feet above ground. D is worth 2 marks normally. So what is D asking for? How long, right? How long are the buffalo at or above 15 feet? So you could, because this is drawn to scale, 15 feet is right here. Right, so we want to know how much time were they above that 15-foot mark. Okay, so we're gonna do D right here. And normally what you want to do is, if they give you the y value, you want to draw a line at that point. So we're going to draw a line at y2 is equal to 15, and we're going to find that intersection. So let's go ahead and do that. Y2 is 15. So it starts at time 0, right? And then this is where you stop being at 15, right? Like you're dropping here. So it's from 0 until that point that we would consider. So second trace 5. Enter, enter, enter. That's 1.86. Okay. So do I need to subtract it from another time? You know how I maybe don't copy this part unless you feel like it's going to help you. But last time, yesterday's example, if we had something like this and you draw 15, okay, then you need to find the first time and the second time, and then you have to go delta t, t2 minus t1. Okay, this is just a side note. But in this case, we don't, right? We just do this. It starts at the highest point and then it drops. So if you draw your 15 line, right? I should do y is equal to 15, but you get it. All you need to find is just this one time. Because time 1 is what? It's 0, yeah. So time 2 is 1.86. So does it make sense to go 1.86 minus 0? If it makes sense to you, go for it, but it's not necessary. Okay? So in this case, we would just say 1.86 seconds. That's it. That is the time. E, state the domain and range. You should be pros by now. What will be your domain here? Time 0 until the buffalo hit the ground. So that happens at 2.56 seconds. For my range, you do hit the ground. That's the lowest y value acceptable. And the highest we ever go to is 32. And there you have it. There you have it. I'm going to sneak in the other part that I never finished last time. So if we go to 36, 36 for H. So I'm just going to recap what happened here, right? This was the baseball being hit, right? At a height of 4, we reached the maximum height here after this much time, and then it hits the ground. Okay, that's the very original scenario. But what does H? H is saying what? State the domain and range, assuming the ball was caught at 6 feet above ground. So it doesn't hit the ground, correct? So for this part, for H, I'm going to erase that because I need more space. So word problems is what you need to master. Okay. So let's make a rough. I really like a sketch to help me out with the domain and range. We go from 0, 4, it gets hit, maximum height, and then it gets caught here. We start at 4. This is higher up, correct? The only thing I know for sure is that the height that we're catching it at is 6. I just don't know this part. Okay. What is my range? My vertex is still 3.57, 66.5. How would I find this using my calculator? If you have y, you let y2 equal to 6, right? y2 equal to 6, and then you go second trace 5 to find the x value. Okay, so we'll let y2 equal to 6, and you go second trace intersect. I would, if you can catch up to me on this one, that'd be great, but if not, that's fine. So I'm going to let y2 equal to 6, but my window is going to be off. I know that already, so I'm going to walk you through that again. Okay, I just need the y max to be higher. I don't know, let's go 100. That works pretty good actually. So I need to find this right here, 6. So whenever, listen carefully, whenever I give you a y value and you want to find the x value, this is how you do it. Okay, you let that y value, you enter that into y2, and then you find the intersection. That will give you the x value. So let's go over. Enter, enter, enter. That's 7.09. 7.09. Okay, that's how I found it. 7.09. So this is almost like a different story. Okay? You'll be okay, guys. If you're a little worried right now, just try a few, okay? So what's my new domain right now? 0, right? When the ball gets hit, and then it gets caught at 7.09 seconds. Okay. What is my range? Let's see. What's the lowest y value I have? 6 is higher than, right? So 4 is the lowest. What's the highest? 66.5. So earlier here, it does not get caught, right? It hits the ground, so we just go times 0 to 7.25, and then the lowest height it ever reaches is 0, and then 66.5 is the highest, right? So this now changed because it stops there. Okay? That's why this all had to be redone. And yes, this is a lot of work. This is almost like a standalone. I could give you this question again, okay? Just saying that it gets caught 6 feet above ground, and then you would have to do that extra step to figure that out. What is I? Here, read that carefully, read it, okay? Write another equation that would model the path of the ball with a lower maximum height. How would you do that? Which one, I don't know if you remember, which one of these 3 numbers here would you want to change to make this happen? The constant, is that what I heard? Yes. If you change the back number here, if you increase it, the whole thing goes up. If you decrease that, the whole thing goes down. Okay? So you're going to want to decrease C. That's what we're going to write down in our notes. So go to your notes. And so you will say decrease the value of C. Right? So one example could be h of t, I will copy everything except the last value. So you could go 3.99, you could go 3. Okay. I think I'm going to go with 3.99 just to make the point. Okay. So essentially, right, if this is your first curve, the new one will be slightly lower, slightly. Okay. So that's what's going to happen there. Okay. What is the time? I'm going to give you some class time to work on these, so you can ask questions as you're working through them. Okay. I assigned pages 38 to 39 after yesterday's lesson. So if you didn't do either of them, 38, 39, then you now need to keep going on 39. Okay, that's where you need to go. If you're done 38, 39, I'm going to say 40 all the way to 41. So this is what I'm going to say right now. I'm going to go to 39, and I'll just say work on 39 to 41. Okay. And I will tell you this, not all parabolas are going to be doing this. Not all. You will, if you keep working through 40, some of them start looking like this. Okay? So that's also good to encounter because parabolas do not always face down. Okay? So use the time. It's yours to take advantage of. And I already posted the key to all of these, so do that. Check your answers once you've done them, okay? I'll pause here. Okay guys, I'm just gonna sneak in the key here for page 40, was it? 39. I'm not gonna solve it, I'm just gonna explain a few things, okay? Just listen, okay? Some of the questions I had were, when do you include both x-intercepts and when do you ignore one of them? Well, if this x-intercept, if this parabola goes and is outside your domain and range, we ignore it, right? You can't have negative time. In this case, negative distance isn't acceptable. But regardless of how you worked with it, what do you notice about this equation here? C is what? You would say C is missing or C is 0. So your y-intercept is 0, 0. And guess what? 0, 0 is the origin, which means it's also going to be your x-intercept. You either find it using your calculator or you just realize, oh, the origin is both. The origin is the x-intercept and the y-intercept. Okay? So in this case, both x-intercepts are included. We're starting on the ground. And then I find the vertex. Most of you found it, so that's good. What else came up here? Well, I guess you'll find out the rest as you work through this, but just make sure you work through them, okay? Same with this one, the plane that's being thrown here. A is positive, so this graph is going to look different. It's going to go up like this, okay? So you gotta really make sure, work through the key to understand what's happening here. One more thing. You listening? Okay. If it ever asks you how long did this thing stay under or above a certain height, when you graph that line and it cuts through it more than once, guess what? You need to figure out both times and subtract. If you graph your line and it only touches it once like this, like you only notice that it stops there, it only touches it once, then you just go find that and subtract it from 0, right, from your starting time. And so that is the time it spent above or below. You got to watch out for the wording, okay? So that's going to happen here as well. for the AC that you're gonna get, okay, I will probably base it very much off of one of these 4 questions that you've seen on here. It's not gonna be the same, even if it is the exact same people, equation, all of that, I can very much change it on you, all right? And I'm probably not gonna I'm just gonna let you know that that's the style you can expect, okay? That is for tomorrow. Thank you guys.